Okay, so regarding the magnetic media devices, these are the things that you need to write, right? And we came here with the topic of secondary memory, which we completed last week. So we write about these things. Is there anyone who is still writing about these things? Okay, so moving forward, and yeah, so like it's better you draw this diagram, this particular diagram at home. So leave some space for these people. If you can take a small picture or a printout of this, so you can have a printout and paste it onto your book, or otherwise you can simply draw it, right? So leave some space for this, like 6 to 7 rules, right? Then you can write about the components, right? And we are not going to write a lot about these things, right? So under that, after the space that you have leave to draw this diagram, 2.44, you can write about the platter, right? And I think you can remember the video that we saw last week. So platter means this, I told you there is a component which is something very similar to a CD. And the difference of a platter and a CD is CD can write only on a one particular surface. Platter can write the things in both the surfaces, right? And to read the data on that platter, this particular, what you call the head is going to be used. So at this point, there is a head. So these are the actuator arm, right? So with that, from this head just over here, we'll read the data on the disk, right? So let's write about the platter. Yeah. Yeah, it's better we write these people. It says what is the platter.
Then we should keep digital space for drawing that, no, sir?
Yeah, like 6 to 7 rules, right? So it's according to your plan. If you are going to draw it much larger, so you may keep more space. Somehow you have to draw this 2.44 figure. So under that picture that you are going to write about these things. Oh, I'm sorry, hold on. Let me know when you are done, people. Okay, one is done. How about others? All right. Is there anyone who is still copying this? All right, so moving forward. Okay, these things. People, sorry about that. I had to run to my kid. Okay, so I think everyone is done with this. So let's go with the magnetic tape one. So example number 2, the magnetic tape. And regarding it, yeah, it's better you write down about this. So magnetic tape is the other media that we can use. I think you have seen this cassette in your real life. So that small, the brown color tape is the one that we call magnetic tape in the cassette. But when it comes to the other kind of magnetic tapes, they comes in a little bit bigger manner and more lengthier manner, right? ප්‍රමාණිනුත් පොඩ්ඩක් ලොකුයි දිගිනුත් වැඩි. ඒක හරියට අර movies වල තියෙන movie reel එකක් වගේ. Right? But the only thing is the reading and writing is very slow using this, right? But the quality wise, it is it is providing us better quality, right? So that's one another magnetic type of medium. Right, one is done. How about others? Yes, Anushi, I will go through that. Now, the magnetic tape means another magnetic type of media. I'll show you how the magnetic types are going to store the data in the magnetic media, so you can see it clearly. And this magnetic tape is kind of a small tape that we can use, that we can see in this small kind of cassettes, right? You can take it out from the bottom line of this particular cassette, right? So it is cheaper, as well as the data reading and writing part happening in a slower manner compared to the magnetic disk. Yeah. Daddy, can I have this box? No, Susu, it's dirty. Right. People, I'm sorry, I'm getting a little disturbance from my little one. Yeah, Sanashi, is that clear? And people, are we done? Anyone who is still writing? Okay, sure, Sanushi. So like Sanushi is asking what is backup? Like backup is like this. It's like now when it comes to the when we are storing the data, we always take a backup as a precaution in case of we lose some data due to some particular maybe natural disaster or maybe some particular power crash or a particular virus attack. And like it's kind of a precautionary that we take in like if we cannot save the data from the original place, backup will help us to have the data, the same data set, right? So yeah, Rizwan, I'll come to the point after the lesson, Putha, right? Since it is not much related to the lesson that we are talking, right? You can ask me after the session. I'll keep you informed, right? So then, Sanushi, like when we need to protect the data, or like when we have to have the plan B regarding our stored data, if those things are important, what we are going to do is we are going to create a backup and keep it in a safe place. You can create the backups in a cloud storage. Like if you think about my situation, all my notes and all these things, I'm copying those things like occasionally into my cloud storage. So in case if my laptop get crashed or some particular something has happened to my internal hard disk, if those data cannot be accessed, still I can access my same particular data from the cloud, right? So like if you take institutions like banks, they regularly take backups. Like at the end of the day, they back up the system to the another particular server or another particular computer. So in case if they got a problem with the original data, they can refer the backup. So that is what it means by the backup, Sanushi. So these magnetic tapes and all these things are heavily used for these backing up things. Right, great. Okay, so next media is the optical media. It is not the example 3 people. Optical media is the second type that we are going to talk. Before that, we'll watch a little video regarding this medias, right? Let me take the links that I have. And let me share the screen with sound. Yeah, so this is about the hard disk. We watched this thing last week, and I think we haven't watched this. Yeah, so this will show you how to store the data.
You're counting down the seconds until you can skip the ad, right? I get it. But what if you never had to watch an ad again? What if you...
Imagine an airplane flying 1 millimeter above the ground and circling the Earth once every 25 seconds while counting every blade of grass. Shrink all that down so that it fits in the palm of your hand, and you'd have something equivalent to a modern hard drive, an object that can likely hold more information than your local library. So how does it store so much information in such a small space? At the heart of every hard drive is a stack of high-speed spinning disks with a recording head flying over each surface. Each disk is coated with a film of microscopic, magnetized metal grains. And your data doesn't live there in a form you can recognize. Instead, it is recorded as a magnetic pattern formed by groups of those tiny grains. In each group, also known as a bit, all of the grains have their magnetizations aligned in one of two possible states, which correspond to zeros and ones. Data is written onto the disk by converting strings of bits into electrical current fed through an electromagnet. This magnet generates a field strong enough to change the direction of the metal grain's magnetization. Once this information is written onto the disk, the drive uses a magnetic reader to turn it back into a useful form, much like a phonograph needle translates a record's grooves into music. But how can you get so much information out of just zeros and ones? Well, by putting lots of them together. For example, a letter is represented in 1 byte, or 8 bits, and your average photo takes up several megabytes, each of which is 8 million bits. Because each bit must be written onto a physical area of the disk, we're always seeking to increase the disk's areal density, or how many bits can be squeezed into 1 square inch. The areal density of a modern hard drive is about 600 gigabits per square inch, 300 million times greater than that of IBM's first hard drive from 1957. This amazing advance in storage capacity wasn't just a matter of making everything smaller, but involved multiple innovations. A technique called the thin film lithography process allowed engineers to shrink the reader and writer. And despite its size, the reader became more sensitive by taking advantage of new discoveries in magnetic and quantum properties of matter. Bits could also be packed closer together, thanks to mathematical algorithms that filter out noise from magnetic interference and find the most likely bit sequences from each chunk of readback signal. And thermal expansion control of the head, enabled by placing a heater under the magnetic writer, allowed it to fly less than 5 nanometers above the disk surface.
Yeah, so like it's going much into the details. So if you want, you can find and watch this video. So what you have to majorly understand is what they have discussed over here. So like they use this magnetism, the quality of magnetism to store the zeros and ones, which means data, on the magnetic disk, right? So how that is going to happen? It is done with the help of this particular magnetic circuit. Like so, once the current is gone, in the way that the ones and zeros are being fed, right? So these things will be changed into ones or into zeros, right? Later, this kind of, they mention it like what? I remember they were saying a very nice name. Yeah, magnetic reader. The magnetic reader can read the magnetism of these particles as 1 or a 0, right? So this particular thing write the things, and this particular magnetic reader will read the data, right? So that is how a particular magnetic media is going to act. People, is that clear? Did you got a clear idea about how the magnetism works on the disk and how those things are being read and write? Okay, so now we are going to move to the optical media. So optical media is the second type of data storage. So optical media, why it is being said as optical media? Because it uses a laser beam, which is considered as an optical beam to store the data, right? So they use this laser beam to write the data onto the optical media, as well as to read the data to the optical media. So like when we are writing the data, what this optical media or the particular laser beam is doing is like it is burning the surface of the optical media in some particular pattern, right? And now you will see within a moment how these burnings are happening. That is why when the CD is being written with some particular data, we use the term a CD is burning, right? So burning, it actually burns the surface of the CD. So there are places which is not being burned and has been burned. So like the places where it has been burned is considered as a 0, and places where it has not been burned, they considered as 1s. All right. So, and when it comes to the real world, there are several different optical media. So the very first kind is the CD, right? So you have seen this. And for CD, there are 3 different types, right? Which is CD-ROM, which means compact disk read-only memory. So when it is a CD-ROM, there are data already inside it. We can put it inside a CD-ROM and we can just read that particular data from the CD reading device. All right. When it is CDR, that means CD compact disk writable one. It's just a write once. It will only support to write just once on the disk. So that, of course, again, when we are purchasing it from the market, there is nothing inside the disk. So using a particular what you call a CD writer, we can write some data onto that CD just for once. We can't write it again and again. When it comes to the CDRW, it is meant as CD rewritable. So CD rewritable is kind of an optical media where we can erase the data on the CD and we can rewrite some of the contents. All right. So that is how these 3 types are being developed. So same goes with the DVDs. There are DVD-ROMs, DVD-Rs, and DVD-RWs. And DVD stands for digital versatile disk, right? So, and again, when it comes to the DVD, it has much greater capacity compared to a CD. CD is just having the capacity in megabytes. And when it comes to the DVD, it stores the data in gigabytes, right? And as well as when it comes to the DVD, there are DVDs where we can store the data on both the sides of the DVD, like a platter, right? And the latest technology is called the Blu-ray, right? Or we can say BD, Blu-ray discs. So it is again used to store the data in a very big manner. Like when the CD is having 650 to 900 megabytes, DVD has 4.7 to 9.4 gigabyte of capacity, and Blu-ray, look at this, 25 to 128 amount of data can be used inside the Blu-ray. And when it comes to the Blu-ray, there is nothing called Blu-ray rewritable. It says Blu-ray RE, recordable, erasable, right? So it is kind of a rewritable thing, but it refers as RE. As well as Blu-ray is capable of recording the 3D movies as well, right? So those kind of categories are there regarding the optical media, right? So let's quickly write about these things. Optical media have the heading. That means it's the second category. First category is the magnetic media. Now we have optical media. right, this can be written. And then you may copy the first two columns. First two columns of the table. Only device and type will be there.
Excuse me, sir. Sir. Excuse me, sir.
Yes, Rizwan.
Sir, should I write the size also, sir?
It's a small detail. Doesn't matter. It's better, neither. Like just you can have a curly brace to the all three types and mention the capacity as well.
Yes, sir. Okay, sir.
So I drew the table. Where should I write the size?
You draw the entire thing.
Yes, sir.
Like if the table penetrates the all the page, can you mark it like this too? For these three things, like somewhere over here.
Okay, sir.
Right. So are we done, everyone?
Yes, sir. Done.
Okay, how about others? Anyone who is still writing? Okay, so moving forward, so you can continue the same table to write about the DVDs and the Blu-ray discs. So we better mention about these people. I'm moving the table a little bit lower, so you can write the other line as well. And mention the capacities as well, like we did before. Okay, are we done, people?
I'm in the last one, Blu-ray 3D used record video.
Okay, okay. Go on, go on, go on.
Okay, sir.
Okay, one is done. How about others? All right, so shall we move forward? Is there anyone who is still writing? Okay, so we are going to see now. There is a very interesting question, people. Like all these optical media, if you take the CD, DVD, and Blu-ray, both all three things are coming on the same size. But if you go through the capacities, they are quite different. Like if you take the CD, it has 650 to 900 MB kind of capacity, and when it comes to the DVD, it's like 4 to 5 times bigger. When it comes to the one-sided DVD, if it takes the two-sided DVD, it's going to be like 10 times bigger. And again, when it comes to the Blu-rays, again, it's kind of a 10 times bigger, but physically they are in the very same size, right? So let's see how these things can be changed, like how they are going to store more data in the same size of a surface, right? There's a short video for you to watch. Let me share it with you now.
How do Blu-ray and other optical discs work? Blu-ray is the descendant of Laserdisc, part of a group of storage media collectively known as optical discs. CDs, DVDs, and later Blu-ray discs are some of the best-known examples of these media. These discs use the same form factor, and the devices that read them use lasers. Optical discs have a layer where pits and flat area contain the disk's data in simple binary.
Okay, I think you can hear me clearly, people. So here they are showing you how the burning process has happened. I told you, like when it comes to the CD surface, the laser beam or the optical media is literally burning the surface of a CD. So when it is burned, like you can see, you can't actually see these particular burning spots because they are very tiny and small, very small. But this what actually happens. The metal diga that means a deeper burning part. Right? These places are not the burning points. Right? So likewise, this surface has these pits and the flat areas. Right? So these are called pits. Me burn karama podi pit එකක් හැදෙන්නේ. Other places are flat areas. Right? So later you will see what is indicated by a pit and what is indicated by flat areas. Right?
A pit represents 0, whereas a flat area represents 1. A laser is pointed at the disk as it spins. When the laser light hits a flat area, it reflects towards a photoelectric cell, which then detects the light. When the laser light strikes a pit, it doesn't get reflected towards the photoelectric cell. This way, the photoelectric cell can interpret the laser's light as binary data. Reflected light equals 1, no light equals 0. This binary is then processed by a computer as data, a movie, or music, for instance. How much an optical disc can store depends on how small the pits can be made on the physical disc and the type of laser being used to read the disc. For instance, Blu-ray uses blue lasers, which have a smaller wavelength than the red DVD lasers or the infrared lasers used with CDs.
Now, this is the point which explains why, like how the same physical size discs can have more data onto it. So you can see like the Blu-ray disc is given a very small pits and the flat areas comparing to the CD. Right? So, laser beam එකේ ප්‍රමාණය මහත කොච්චරද කියන එක. Right? So the Blu-ray is using a very tiny laser beam comparing to the DVD, and DVD is using again a thinner laser beam comparing to the CD. Right? So that is how they use the same surface to have different kinds of pits and the flat areas.
Because this smaller wavelength makes the Blu-ray beam more precise, more data can be stored on the same surface area, approximately 5 times more than on its predecessor, the DVD. Added to that, Blu-ray is a so-called third-generation optical disc. At the time of writing, fourth-generation optical discs are still in development, with Ultra HD Blu-ray poised to supersede regular Blu-ray in the near future. If you want to know, for instance, how VHS works, let me know in the comments.
Okay, they are giving you the hint, the next generation of the CDs, which is called the Ultra HD Blu-ray, are going to be there, right? So we'll see when it is here, how capable it is than the Blu-ray, right? So that is how the optical media happens. All right, so that brings us to the solid state devices, right? So the solid state devices, why it is said as a solid state, unlike the magnetic media as well as the optical media, they don't have any movable parts, right? The pen drives, the SD cards, and all these things are categorized under this solid state devices, right? So we can't, we don't see anything movable when it comes to these kind of things, because the circuit is inside these little chips or this particular plastic casing, right? So it is considered as the solid state devices, right? So this is the third category, which says solid state devices. So let's copy this down, people. So solid state devices. And as an example, we can have the USB flash drive and the SD cards. Rizwan, are you referring to a scan disk?
No, sir. SanDisk. I have heard such things.
SanDisk.
SanDisk.
Yeah, so like SanDisk. I've heard the word zip disk and all these things, but SanDisk is quite new for me. Like, let me check on that. Yeah, it's kind of a brand name, Rizwan.
Oh, sir.
Yeah. So like it's the same thing. It's a brand name. So like we got Imation and all these things are like the SanDisk is also taken as a yeah. It's a brand name. There are different kinds of brand names.
Okay, sir.
So I'm moving the knot a little bit up ahead. So if you are done with the first example, you can go with the second one. Yeah, it's better we write about like this. Okay, so if you are done, we can end the session just for today. And for the memory cards, people please write this as an example so we can done the session for today. Right, so by next week, we are going to continue from the computer ports, right, which you have seen when we are assembling the computer. So we can continue from that point onwards. So if you're done, you can disconnect from the session. So thank you very much, everyone. The video will be there in the website by tomorrow morning. So thank you very much. I'll see you on next week for the very same time.